हेलो गाइस, कंसेप्ट विद एप्लीकेशन चैनल में आपका बहुत स्वागत है। आज हम आपके लिए लाए हैं एक एक्साइटिंग टॉपिक जिसका नाम है थेवेनिन थ्योरम। इसके बारे में हम बहुत ही अच्छे से जानेंगे, एप्लीकेशन भी देखेंगे। तो आइए जुड़िए मेरे इस वीडियो के साथ। अपने दोस्तों को भी लाइक, शेयर और सब्सक्राइब कर दीजिए। तो देखिए, आज हम डिस्कस करने वाले हैं बेसिक्स ऑफ थेवेनिन और एप्लीकेशन बेस्ड ऑन दिस। तो हम लोग एक बेसिक सा सर्किट ले लेते हैं। यहाँ पे हमारे पास एक वोल्टेज सोर्स है, एक 10 ओम का रेजिस्टर है, 40 ओम्स का रेजिस्टर है, 20 ओम्स की एंड 20 वोल्ट्स की एक बैटरी है। सो हियर वी गो। थेवेनिन थेवेनिन इज यूज टू सिंप्लीफाई कॉम्प्लेक्स सर्किट। थेवेनिन थ्योरम क्यों यूज़ करते हैं? क्योंकि कॉम्प्लेक्स सर्किट हमारा सिंप्लीफाई हो जाता है। स्टेप 1, अप्लाई थेवेनिन। मैं सीधा आपको क्वेश्चन के थ्रू इसकी एप्लीकेशन भी बताऊंगा और सीधा यूसेज बताऊंगा, थ्योरी नहीं लिखवा रहा है यहाँ पे। फॉर फाइंडिंग थेवेनिन वोल्टेज, ओपन सर्किट टर्मिनल्स ए एंड बी। सो बेसिकली हम लोग को जहाँ भी थेवेनिन निकालना होता है, हम पहले उस टर्मिनल्स को ओपन सर्किट करते हैं। फिर देखिए, इक्विवेलेंट सर्किट बना लीजिए। हमने ए और बी को ओपन सर्किट किया, फिर इक्विवेलेंट सर्किट बना लिया। अब स्टेप 2, अप्लाई केवीएल इन दिस सर्किट। सो you all guys know to apply KVL, so here we go in this way. Plus minus 10 volt rise, so 10 minus 10i, I current इस डायरेक्शन में बह रही है, minus 20i इस डायरेक्शन में I current बह रही है, plus minus drop, so minus 20 equals to 0. So here we get I equals to minus 1 by 3 ampere. Now to find VTH, apply KVL in loop 2. This is my loop 2, this small one. So apply KVL here. VTH equals to minus 20 into 1 by 3 plus 20 equals to 40 by 3. So I hope you all guys know basic KVL, 13.33 volts. Step 3, finding Thevenin resistance. So basically we draw a equivalent Thevenin circuit in which Thevenin voltage is required and a Thevenin resistance is required. So what is the procedure to find Thevenin resistance? So if we have an independent voltage source, I am talking here about only case 1 where we have only independent sources. So if we have a voltage source, then it is replaced by short circuit. If we have a current source, then it is replaced by open circuit. So after doing this, we draw our equivalent circuit. So it looks like here. So basically from here we have short circuited this 10 volt source, so it will be replaced simply by a wire, and second 20 volt source also, so it will be replaced by a short circuit wire. So between A and B terminals we get 10 ohm resistance, 20 ohm resistance and 40 ohm resistance. All are in parallel, so you can find equivalent. It is coming out to be 5.71 ohms. So here now we will draw Thevenin equivalent circuit. So basically Thevenin equivalent circuit consists of a VTH, what we have found Thevenin voltage, RTH and RL. RL is the resistance which was connected in the original circuit between A and B. जहाँ पे हम लोग कैलकुलेशन कर रहे थे वो RL था 40 ओम का. So this circuit gets converted into VTH, which we found out to be 13.33 volts, our RTH 5.71 volts, 40 ohm resistance. So hope you guys understood the basic Thevenin theorem. So here we are going to discuss its first application, which is the BJT question. BJT question came in GATE instrumentation paper in 2026. So here is the question. I'm not discussing the BJT in detail, just I want you guys to know applications of Thevenin. So here is a basic BJT circuit. Hope you guys, all guys know, here is the base terminal, collector terminal and emitter terminal. So basic information which you will need to solve the BJT circuit is, assume the transistor in active region. So IC equals to beta IB and IE equals to beta plus 1 IB. If we have to apply Thevenin theorem, because this circuit is a bit complex, I will bring a comprehensive course on BJT, then you will understand better. But for the time being, you just listen to me what I am saying. For example, if we have to find Thevenin voltage VA on this terminal, so What are the basic steps? Note, while applying Thevenin, we remove transistor to find VTH. So just do as I say. So just remove the transistor from here. Here was our transistor in the original circuit. Uh, so uh, 5 volt source, VA, what we have to find, and 5 kilo ohm resistance. So basically, if you have removed the transistor, no current flows in this branch. So directly by applying VDR, you can find VA. VA is just equal to 5 by 2, 2.5 volts. Now, as we did in the previous question, we have to find RTH also, Thevenin resistance. For RTH, we will do the same process, but just keep in mind that we will ground the 5 volt source, because as I have said that we are finding RTH, we ground the independent sources, independent voltage source, and for current source we open circuit it. So RTH will be just 5 kilo ohm parallel to 5 kilo ohm. So RTH we get as 2.5 kilo ohm. So just draw the equivalent circuit. It was our point which we have marked VA, and connected to this is the VTH 2.5 volts, as we have done in the basic question. RTH is 2.5 kilo ohms, 5 volt battery 5 kilo ohms. Here is the collector terminal, base terminal, emitter terminal. Now applying KVL in loop 1, no need to pay attention to this, but just I am telling that it is the Thevenin is useful in various applications, from which BJT is one. So applying KVL, we get the IB and IC current. So we have what we have discussed in the video, basic Thevenin theorem. Applications, just now we have studied only one. So thank you guys, please do like, share and subscribe, and hit the bell icon for upcoming videos.